This section is about quadratic forms. A quadratic form is an equation which is not a true quadratic equation, but it resembles one. It carries many of the same characteristics to it. But before we really dive into this, we need a discussion about square roots, and I want to go a little deeper in square roots than you maybe have ever thought about before. And so let me start off. Why do we call, for example, the square root of 9, why do we say that equals to 3? Well, it's because 3 squared is equal to 9. But you could also say that's true about negative 3, couldn't you? Because when you square negative 3, you also get positive 9. So would it be okay to say that the square root of 9 is equal to negative 3? No, it's not okay. What evolved over the centuries was an agreement to treat the square root as a mathematical function. Now you're going to study mathematical functions in some detail in a later chapter, but the hallmark of a mathematical function is that when there's an input value, the function does something to it and gives you a single output answer. So to say that the square root of 9 is equal to two different numbers means that there would be two outputs and it would not be a function. So we define square root to have a non-negative answer. Now non-negative means it's either positive or it could be 0 in the special case of square root of 0. In other words, a square root can never equal to a negative number. So for example, if you had a problem like this, the square root of 4x plus 7 equals to negative 2, it cannot be solved. There's no solution. And because we cannot have a square root equal to a negative number. Now it is possible to attempt to solve this problem by squaring both sides. If I squared both sides, for example, so I'll square the square root, I'll square the negative 2. When I square the square root, I'm going to get the radicand, 4x plus 7. And that equals to positive 4. And then we could finish solving here. 4x would equal to, negative 3. So x would be negative 3/4. And there's nothing wrong with having a negative answer for an equation. The problem is that when I plug negative 3/4 into here, I'm going to get the square root of 4. And so in the check, when we check it, put this number into here, turn the crank, we get the square root of 4 equals to negative 2. And that violates our notion that a square root cannot be negative. So, so what's the bottom line here? It's possible to fool ourselves in solving equations which have square roots in them. Because it turns out, as you'll see, those kinds of problems always involve squaring both sides of the equation. And when you square both sides of an equation, you can create a false situation. For example, 1 cannot equal to negative 1. But if you squared both sides, you would get 1 equals to 1, which is true. And so, you've seen this before. In the very first section, we saw some equations involving fractions called rational equations, where it's possible that there was no solution because the answer would cause division by 0. That's because our method of solving has a potential flaw in it that we have to guard against. Our method for solving these also has a similar potential flaw, and so we need to be able to be alert to checking answers to make sure that they work. So we'll see this again as we work through this. As you work through this section, you'll see this. But mainly, I want to get across that a square root cannot be negative. Neither can a fourth root, or a sixth root, or an eighth root. Anything with an even index to it, an even root, cannot equal to negative. Now, a cube root could be negative, for example. And because cube roots are okay. For example, the cube root of positive 8 is 2, and the cube root of negative 8 is negative 2. So if you were to raise this to the third power, you'll get positive 8. If you raise this to the third power, you'll get negative 8. So we don't have to worry about that potential when solving a problem with cube roots in it. From cubing each side, we don't have to worry about the potential of creating a false situation. And that would go for fifth roots and seventh roots, any odd index. It's just the even ones, and primarily the square root is what we're going to worry about in this section.